So welcome to part 2 of this page 47 characteristics of chemical reaction reading. I had to do it in parts because I couldn't upload a 20-minute video, so I've had to do it in parts. So sorry about that. Sorry that there's a part 1 and a part 2. Evidence of color change. The color of a substance may change when its chemical composition changes. An example of a color change as evident of a chemical reaction is seen when copper wire is placed in a clear solution of silver nitrate. The production of the reaction is a blue solution. A color change represents more than just a physical change, such as diluting a substance or adding food color to a substance. The physical change from food coloring are not evidence of chemical reactions. Have you ever seen a fireworks display? These colorful little explosives are not just entertainment. When each firework is ignited, one or more chemical reactions take place. The color of the display in the sky is determined by the elements or compounds involved in each chemical reaction. What can you observe during a fireworks display? Perhaps you hear loud sounds, see bright colors, and feel the warmth from the explosion, which are evidence of a chemical reaction. In a chemical reaction, molecules can change through the rearrangement of their atoms. More specifically, atoms of the reactants, remember that's on the left-hand side of the arrow, can rearrange to form new molecules. That's this side here. A chemical equation can be written to show what happens to the atoms of a chemical reaction. A chemical equation is written like this. We've written this down a couple different times in our notebook. The arrow in a chemical reaction means produce or are converted to. If you have ever seen water, you have seen the result of a chemical reaction. In this reaction, oxygen gas, O2, and hydrogen gas, H2, rearrange to form water, H2O. The balanced chemical equation for this reaction is written like this. Let me explain why they call it balanced. So if you look right here, there are 2 oxygen atoms. If you look over here, this subscript is technically a hidden 1, and this coefficient 2 means that there are 2 oxygen atoms. Now let's go over here on the reactant side. This subscript 2 on the hydrogen, along with this coefficient 2 multiply together, that means that there are 4 hydrogen atoms. Now let's go over here. We can see it again here. There are 2, the subscript 2 times the coefficient 2, so there are 4 hydrogen atoms here as well. So we call this balanced because there's the same number of oxygen atoms on both sides of the arrow, and there's the same number of hydrogen atoms on both sides of the arrow. It's just like whenever you solved equations in math this year. When you add or subtract or multiply or divide both sides by the same number, you're keeping your equation balanced. Whatever you do to one side, the equal sign you do to the other side, well, you keep your equation balanced, and this is the same thing here. Our chemical equation is balanced because we neither lost nor gained any atoms. In the chemical reactions, the reactants have properties different from the product's properties. For example, oxygen gas, and hydrogen gas have different properties from water. In the gas form, water vapor may look similar to both hydrogen gas and oxygen gas. They are all colorless gases, yet they have different chemical properties. Oxygen is very reactive compared to both hydrogen gas and water vapor. I love this illustration here. So this right here, these are the reactants. See how there's an H2, there's one H2 here, and there's one H2 here. That's this right here. That coefficient means that there are two H2s. The H subscript 2 is the grouping together of these two hydrogen atoms. And then here, these two oxygen atoms are grouped together. That's this subscript. Now, if you look over here, this H2O is one water molecule. See how the hydrogen, and the oxygen are connected? That right there is one water molecule. Here is a second water molecule. This H2O is a water molecule, and then the coefficient means that there are two water molecules. So not all reactions combine elements to make compounds. Some reactions break down compounds into elements. When electricity is passed through water, the molecules react by breaking down into hydrogen and oxygen gas. The reaction equation is, here's the reactant, here's the products. So this right here is two water molecules. This right here has a total of 4 hydrogen atoms. And this right here has 2, because of the coefficient, oxygen atoms. And again, it's the same thing over here. This right here means 4 hydrogen atoms, and this right here means 2 oxygen atoms. So it's balanced. There's not any more or any less hydrogen or oxygen atoms on either side. It's the same number. Bread dough is a mixture of ingredients that include flour, salt, sugar, warm water, and yeast. When these ingredients are combined, the ball of dough begins to expand or rise. This reaction is caused by yeast, which is a living organism that becomes active in warm water. Once activated, the yeast converts the sugar and the dough into alcohol and carbon dioxide through a chemical reaction. This process is called fermentation. The balanced chemical equation for this reaction is here. Oh, wow. So if you'll see, this subscript 6 on the carbon means that there are 6 carbon atoms. And if I go over here, here's 2 of them. Now there's 2. This right here, that subscript also hooks to this. So there's 2 more carbon atoms. And then over here, this subscript is hooked to this. So there's 2 more carbon atoms for a total of 6. So let's look at the hydrogen. It says that there's 12. So there should also be 12 over here. This subscript 3 times this coefficient 2. So that's 6 hydrogen right there. And then this 2 times this 2. So that's 4 hydrogen here. And then right here, this hydrogen, this coefficient way over here applies to this. So there's our total of 12 hydrogen atoms. I need to be writing this down. And then the oxygen, it says that there's 6 oxygen atoms here. So let's go over here. This oxygen atom here, its subscript is a hidden 1, but it has this coefficient. So there's 2. And then this oxygen, there's a subscript 2 and a coefficient 2. So multiply together, that's 4. So there we go. There's our 6 oxygen atoms as well. The release of carbon dioxide, which is a gas, causes the bread to rise. the carbon dioxide, also gives the bread its light, airy texture. The alcohol produced by the reaction gives the bread its final taste. During baking, the alcohol evaporates. Here's something that could be super cool. If you've never made homemade bread and you have parents that have, if they've got time, since you guys are home, ask them if they'll show you how to make homemade bread. It's super cool. If you or your parents have never made homemade bread, there are tons of YouTube videos. You will need some flour, some sugar, some yeast, a little bit of salt. Now, the yeast and the warm water and sugar all have to be combined together, and you have to be careful that your water's not too warm. The directions on the yeast package will tell you. Got to be a little bit careful that your water's not too warm, or you'll actually kill the yeast. And we did this experiment with the 3 balloons in the little bitty water bottles. We had a different color balloon on each water bottle, and we got to see that when we did not add honey, which is a sugar, when we did not add honey to our water and our yeast, we never got any bubbles, and we never did get to see the yeast expand. But when we did, in fact, add sugar, the honey, we got to see our yeast activate, and we got to see bubbles. It was a lab that we did. It was an observatory lab that we did. It was actually on page 20 of your lab booklet. Okay, so your lab book should look like this right here, and as you answered the Edpuzzle questions, we gave you hints on these blanks, so just double check and make sure that your blanks match what you see here.